Welcome to episode 1 of our series Back to Basics. The program we have for this second season is pretty interesting, all about utilizing data. That's the agenda you know, and therefore we'll start right away with the statistics. From Wikipedia, statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. Let's look at that definition in more details. Collecting information about population, crops, floods is the first meaning of statistics. They were already performed by the Egyptians and the Romans, who were performing population census. Data collection has taken a new dimension in the 18th century when data was not only collected but also graphically represented to, for example, express death statistics from a military campaign that led in the 19th century to techniques used to analyze data. In applying statistics to a scientific, industrial, or social problem, it is conventional to analyze a statistical population. Populations can be diverse groups of people or objects, such as all people living in a country, or every atom composing a crystal. As it is often not possible to study the whole population, representative samples are considered. This is well known for political surveys to ensure that the sample reflects the opinions of the whole population. So, what is the history of statistics? Like any human science, modern statistics is the result of the evolution from a human power-based to the current computer power-based execution. The mathematical foundation of modern statistics were laid in the 17th century with the development of the probability theory. The modern field of statistics emerged in the late 19th and early 20th century in 3 stages. The first wave, at the turn of the century, was led to transform statistics into a rigorous mathematical discipline used for analysis, not just in science, but in industry and politics as well. Concepts of standard deviation, correlation, regression analysis, and the application of these methods to the study of the variety of human characteristics raised at that time. The second wave of the 1910s and 20s saw the publication of textbooks that were to define the academic discipline in universities around the world, de facto standardizing terms and concepts. The final wave, which mainly saw the refinement and expansion of early developments, saw the statistical methods being applied in all fields that involve decision-making, for making accurate inferences from a collated body of data and for making decisions in the face of uncertainty based on statistical methodologies. The use of modern computers has expedited large-scale statistical computations and has also made possible new methods that are impractical to perform manually. Statistics continues to be an area of active research, for example, on the problem of how to analyze big data. Statistics is all about understanding the world around us. To understand this phenomena, 2 approaches can be considered. Observational studies, such as surveys, where the system under study is left to his own device and the statistical analysis is used to describe it as is. And the experimental studies, where the system under study is manipulated, usually after an observational study. Here, factors that are supposed to influence the system are applied on the system. The statistical analysis role is to determine if they have an effect and to quantify this effect. Fully understanding a phenomenon is usually impossible. It originates from different reasons. First, we cannot describe the system fully because we cannot measure everything. and the sample at our disposal may not cover the whole depth of the phenomenon under study. Second, observations contain errors that makes the representation of the system a little bit fuzzy. I mean, observational errors, unit errors, etc. And thirdly, our statistical tooling is not good enough, for example, to capture non-linear relationships. With all these restrictions, statistics is really relevant to better understand our world. We must just be humble in our approach and be aware of the limitations. For example, the statistical analysis of the earthquakes leading to tsunamis originated an undersizing of the robustness of Fukushima nuclear power plant that, among other factors, led to the disaster we all know. Two main approaches are used in data analysis. Descriptive statistics, which summarizes data from a sample using indexes such as the mean or the standard deviation, and inferential statistics, which aims, through defining relationships between variables or data descriptors, at predicting an output from a set of input data. The two approaches are in fact very complementary and are usually pursued in parallel. It is now time to try and understand how statistical concept can be applied in day-to-day life. A very popular concept is statistical distribution. A distribution in statistics is a function that shows the possible values for a variable and how often they occur. A good example is the Weibull distribution to predict time to failure. It is used by manufacturers to understand how long what they produce will work. It relies on measuring a failure distribution, meaning the proportion of failures that happened after a certain amount of time or kilometers or else. It ultimately allows determining what percentage of the product should be still working after a certain amount of time. Another good example of how statistics are used is experimental designs and tests. Experimental designs is a way to carefully plan experiments in advance so that results are both objective and valid. In clinical trials and production experiments, where factors can be controlled, testing the difference between factors is key. The efficiency of vaccines is measured this way, by collecting statistics on a test group receiving the vaccine, as well as on a control group with no vaccine injection. Statistical tests are performed to define the significance of the difference. One of the most known tests is the student T test. It was designed by William Gossett in 1908 and was controlling brewing conditions for Guinness. It is called student as Guinness forbade Gossett to publish with his own name for competition reasons. Finally, correlation between sets of data are the last topic we want to address today. They are widely used and available in all data-related tools. In statistics, correlation or dependence is any statistical relationship, whether causal or not, between two random variables. In the broadest sense, correlation is any statistical association, though it commonly refers to a degree to which a pair of variables are linearly related. Familiar examples of dependent phenomena include the correlation between the height of parents and their offsprings, and the correlation between the price of a good and the quantity the consumer are willing to purchase, as it is depicted in the so-called demand curve. Correlations are usually useful because they can indicate a predictive relationship that can be exploited in practice. For example, an electrical utility may produce less power on a mild day based on the correlation between electricity demand and weather. In this example, there is a causal relationship because extreme weather causes people to use more electricity for heating or cooling. However, in general, the presence of a correlation is not sufficient to infer the presence of a causal relationship. In fact, linearity of relationship is relatively rare in nature. Now that we know a little bit more about statistics, let me thank you for being with us, and I will see you next time. We will speak about business intelligence. See you soon.